Arithmetic operators are used to perform mathematical operations like addition, subtraction, multiplication, and so on. As you can see on my screen, I have written and I have tried to use multiplication operator to multiply two numbers by writing print 5 asterisk 4. So let's try to run this. So you can see answer is 20. Same way I can use addition as well. Let's try to run it. And you can see 5 plus 4 is 9. So this is how you can use arithmetic operators in your program to compute operations. So next in the list is assignment operators. So Python assignment operators are used to assign values to a variables. For example, x is equal to 5 and x plus equal to 5. So let's try to execute this and see value of x is 5 initially using this to statement. Then we added 5 into the existing value of x. So this particular statement says that add 5 to x, whatever value x is holding, add 5 into it, and that's what it is printed here. So these are assignment operators. There are several other operators as well: subtraction, multiplication, division, remainder, exponent in the assignment operators, which you can experiment with. So next set of operators are comparison operators. So comparison operators compare two values or variables and return a Boolean result. For example, we have a value a is equal to 5, b is equal to 2, and we are trying to use the comparison operator in our print statement a greater than b. What will be printed? Let's try and execute the program to check. So you can see that Boolean value true is printed. So if we just invert the operator here, instead of greater than we'll put less than, it should be printed false. So that's how you can use the comparison operators. So comparison operators are used for comparing two values or variables. So let's now move to the next set of operators, which are nothing but logical operators. So Python logical operators are used to check whether an expression is true or false. They are used in decision making. For example, a is equal to 5, b is equal to 6, print a greater than 2 and b greater than or equal to 6. So any guess what it will print? Let's try and run it. So it is printing true. So this particular expression is evaluated as true. So let's see how exactly it is working. Using the logical operators, Python always follows the truth table. Let me show you the truth table, what it is. So here you can see logical AND will always check all the expressions are evaluated true. So here you can see true and true will always become true. Second statement says true and false. So that means AND will always return false because not everything is true, right? Then logical operator OR. So OR has a truth table, true or false. Then it will always return true. And logical NOT operator will always invert the existing value. So here not true become false. If here it is not false, it will become true. So I hope you have understood these logical operators in Python. Now let's move to the next operators. So next set of operators are bitwise operators. So bitwise operators act on operands as if they were string of binary digits. They operate bit by bit, hence the name. For example, 2 is 10 in binary and 7 is 111 in binary. So each digit is a bit in binary representing the decimal number. That's why it is called bitwise operators, because it works on bit by bit. So these are our bitwise operators: bitwise AND, bitwise OR, bitwise NOT, and so on. So this brings to our last set of operators, which are special operators. So Python language offers some special types of operators like the identity operator and the membership operator. So identity operators are is and is not. These are used to check if two values are located at the same memory location. It is important to note that having two variables with equal values doesn't necessarily mean they are identical. So let's see example of identity operators. x1 equal to 5, y1 equal to 5, x2 equal to hello, y2 equal to hello, x3 equal to 1, 2, 3, y3 equal to 1, 2, 3. Now let's try to use these identity operators on these values. So print x1 is not y1. What happens? So it is printing false. That means x1 and y1 both are different values, different memory location. Let's try another. Print x2 is y2. Let's see what happens now. So this has printed true. Now let's try to print x. So x3 is y3. Let's see what is happening. So it is printed as false. So in x1 and y1 are both are equal, so it will evaluate as true, but due to this is not, it will be inverted to false. Second, x2 and y2 both are equal values, both are equal string values, so this is also evaluated as true. Third, x3 is y3. Here x3 is a list and y3 is a list, but both lists are different. They are equal but not identical. It is because the interpreter locates them separately in memory, although they are equal. Now let's see the membership operators. So in Python, in and not in are the membership operators. They are used to test whether a value or variable is found in a sequence. Sequence like string, list, tuple, set, and dictionary. In a dictionary, we can only test for the presence of a key, not the value. So let's see this in practical way. So here, if we try to use the same x3 and y3, we can print 2, because 2 is an integer, 2 in x3. Now let's try it again. Now you can see it is printed true, because 2 is present in x3. Now if we change this number to 6, we know that 6 is not present. And if we try it, we see that it is printed false. That means 6 is not present in x3. Same way we can use x2 as well. So for example, if we use capital H and we try to find in x2, let's save it and run it. So here you can see H is present in hello string, so it is printed true. Similarly, you can test for dictionary, tuple, and set. We have covered a lot today, but here is the special tip I promise. By combining bitwise and logical operators, you can write more efficient conditions in Python, especially when dealing with flags or multiple Boolean checks. Here is how it works. So here you can see we have declared one variable flags with a binary value of this and another variable mask with the value this. Now we can write a print statement, special check, and we can combine the bitwise operator with these two values like flags and mask is equal to mask. So we are using comparison operator here. So this trick checks specific bits in a flag variable, making it a powerful tool for game development or system programming. If you have found this video helpful, please give it a thumbs up and don't forget to subscribe for more tutorials like this. Got questions or need more examples? Drop a comment below and I will get back to you. Happy coding!